In this last section, I want to say something about the alpha value and errors in hypothesis testing. Now, the alpha value, that's the 0.05 that we see most often. Our level of significance, some cut-off value, sometimes we see it as 0.01. I've got to spoil the fun. Where does this 0.05 come from? Is it really magical? If we find a value less than 0.05, is it absolute proof that something exists, that drug A is better than placebo? Can I now walk out and absolutely believe it? No, I can't. There is no magic behind 0.05. You know now. It's just an area under the curve of a sampling distribution. It would be rare to have found, through taking a sample and doing that analysis, it would be rare to find the results that were found. But that's all it says. It was just at a certain level of rarity to find that difference. It really is just thumb sucked. If we look at the area of physics, they go many, many, many more standard errors away from the mean before they would accept something, for instance, at CERN, at the Large Hadron Collider. In medicine, we choose 0.05 or 0.01. If we chose something like 0.000001, we would have nothing to publish. We wouldn't have any good findings to look at. So 0.05 is this acceptable level of risk. Now, we do state that it's not actually 100% true. It does. We do need to take into consideration the pretest odds, and we'll say something about that a bit later. But if we leave pretest odds for finding a difference outside this for a moment, it really is a acceptable risk, this 5% risk that we do take. That is what the alpha value really tells us. Now, there's some errors that we could make. Now, first of all, we could falsely reject the null hypothesis. Drug A was really not better than placebo, but in the analysis we did, in the sample that we selected, we found a p-value of less than 0.05. And we do reject that null hypothesis, which in reality should never have happened, and that is a type 1 error. The type 2 error, the reverse actually happens. Drug A was better than placebo, but the analysis we did showed a p-value of more than 0.05, so we do not reject, we failed to reject that null hypothesis, where in actual fact we should have. We don't know this, that is what our analysis is, but that really is a type 1 and a type 2 error, and this is the type of table that you can just usually memorize just to remember those. If you look at the top, if our null hypothesis is indeed valid, and at the bottom we failed to reject it, then that's correct. That's what we want. Conversely, if the null hypothesis, in reality, we don't know this, that's why we do research, but if we could know that it really was invalid, and we do reject it, that's also correct. On the opposite side of the coin, though, if the null hypothesis is valid and we reject it, that's our type 1 error. That's the 0.05. And if it's invalid and we fail to reject it, we make a type 2 error.